Good day and welcome. In this lesson, we'll be looking at the compulsory exam question determining the equation of a tangent at the point given equation of a function. So, given f of x equal minus x cubed plus 3 over 2x squared plus 6x, determine the equation of a tangent of f at x equal negative 2. Right? So, first we're going to get the first derivative. That is so that we can get the gradient of the tangent. So first derivative there, 3 times negative 1 gives me negative 3. 3 minus 1 gives me 2. 2 times 3 gives me 6. 6 divided by 2 would give me 3. 2 minus 1 gives me 1. 1 times 6 simply stays 6. Right, now they've given me the x value, so I'm going to substitute that in the first derivative. At x equal negative 2, so there minus 3 minus 2 squared plus 3 minus 2 plus 6, that gives me 4 times negative 3, which is negative 12, 3 times negative 2, which is negative 6, plus 6, so my gradient here equal negative 2. So gradient of my tangent is negative 12. Right, now to determine what we call the point of contact, that is to work out the c value, we're going to sub that point into the original equation. So if I sub in the original equation, it's going to become negative 2 cubed plus 3 over 2 negative 2 squared plus 6 times negative 2. Gives me negative 12. 4 times 3, 12 divided by 2, which gives me 6. Minus 2 cubed, which is minus 8, times negative positive 8. 14 minus 12 would give me then 2. So my point of contact minus 2 and 2. So gradient first derivative, sub in the point given, then sub the point in the original equation to get point of contact. 1 mark first derivative, 1 for the gradient, 1 mark for the point of contact. Another mark there for substitution. Now to find the equation, we can go one of two ways. Y equal mx plus c, where m now is negative 12. Remember the gradient there is negative 12. Right, and then I use my point of contact. This states that x is negative 2 when y is 2. Negative 12 times negative 2 would give me negative 12, not negative, positive 24. If I take it over, negative 24 plus 2 would then give me negative 22. So my c is negative 22, so y equal minus 12x minus 22. Or you can use the equation y minus y1 equal m times x minus x1. So y1, there is 2, so it becomes negative 2. X there is, x1 is negative 2. So minus 12 times x would give me minus 12x. Negative times negative, positive 2 times negative 12 gives me negative 24. If I bring negative 2 over, that becomes negative 24 plus 2. So my final equation, y equal minus 12x minus 22. Alright, so for equation of a tangent, I hope you get the procedure. We will give you a point. This point we'll always substitute in the first derivative to get the equation of the gradient. Then that same point is substituted in the original equation to get the point of contact. The gradient and point of contact is then used together to find the equation of a tangent, which is the equation of a straight line. Right, let's look at another problem. Now in the second problem, determine the equation of a tangent at x equal 2. So we're going to use that value to get the gradient and the point of contact. So first, to get the gradient, we're always going to find first derivative. So given f of x equal minus x cubed plus 6x squared minus 9x plus 4. First derivative, 3 times the negative 1 gives me negative 3. 3 minus 1 becomes 2. 2 times 6 becomes 12. 2 minus 1 becomes 1. 1 times negative 9 gives me negative 9. 1 minus 1 is 0, so x falls away. The first derivative of a constant, always 0. Right, now substitute x equal to 2 in the equation, so there x becomes 2, so wherever I see x I'm going to put 2. So that becomes 2 squared plus 12 times 2 minus 9. 2 squared gives me 4, 4 times negative 3, negative 12. 2 times 12, 24, minus 9. So 24 minus 12 gives me 12, minus 9 is 3. So my gradient of my tangent, m equal 3. Determine the point of contact, x equal to 2 must go in the original equation. So there, if I make x2, wherever I see x, I'm going to place the value 2. So that becomes negative 2 cubed plus 6, 2 squared, minus 9 times 2 plus 4. Right, that gives me negative 2 cubed will become negative 8. 2 times 2 or 2 squared is 4 times 6 gives me 24. 2 times negative 9 gives me negative 18 plus 4, which equals 2. Right, so my point of contact is at 2 and 2. Right, so again, go straight, equation of a straight line, y equal mx plus c. The gradient there was 3, so y equal 3x plus c. According to my point of contact, x is 2 when y is 2. 3 times 2 would give me 6. If I take 6 over, it becomes negative 6. Negative 6 plus 2 then gives me negative 4. So c is negative 4, so my equation reads y equal 3x minus 4. Use the second format, y minus y1 equal m times x minus x1. y1 equal 2, a negative in front of it, so therefore negative 2. x1 becomes 2. So there, 3 times x would give me 3x. 3 times negative 2, negative 6. Take negative 2 across, it becomes plus 2. So I have now y equal 3x minus 6 plus 2, which then gives me y equal 3x minus 4. So you must know how to find the equation of a tangent. I hope you understand the process. So I always use the first derivative to find the gradient. Right, and I substitute the point of into the original equation to get the point of contact. Right? And just for interest sake, because we're going to do it next, if I take 2 there, if I say 3 times 2, gives me 6, 6 minus 4 gives me 2. So you see, I can also use the equation of a straight line to work out the point of contact. But that we're going to do when we have to find the equation of the cubic function, given the equation of a tangent, and we have to work back to front. Please like the video, share with any friends that need their help. The more people we help, the better off all of us are. God bless. Bye.